Okay, so graphing radical equations. So to talk about this, you actually want to be able to graph these by hand because they're really easy to graph by hand. But just so you can get an idea of what's happening, take out a graphing calculator or use my graphing calculator from the website and actually graph each one of these calculators, each one of these equations in your calculator one at a time. Or graph them all, but then just look at each graph and know which order they're coming in. So pause the video, write down all three of these equations, and take out a graphing calculator. I'll graph them all on the same graph. And I want you to notice what's happening from the square root of x to the square root of x plus 1 to the square root of x plus 5, how that graph actually changes from one to the next equation. So go ahead, pause the video, and come back to me after you actually have done all those. So what you should have saw was, at the square root of x, the graph looks like this. It started here, and it slants out that way. Now we could find out the coordinates that actually exist here. For example, if I plugged in 1 for x, if I plugged in 1 for x, you may just automatically see what the square root of 1 is going to be. An output of square root of 1 gives you 1, so the y value would be 1. I plug in 1 for x, so I know that 1 output is 1. Then that 2 is going to be square root of 2, which is slightly bigger than 1. It's like 1 point something. Anyway, you can keep finding numbers. You're going to find that it doesn't grow very fast. It goes outwards forever, and it's going to eventually go upward forever. But it's going to take a long time to go upward compared to how fast it goes outward. Like, you have to get way out to maybe 100 before you even get to 10 on the graph. We think about it, square root of 100 would be 10 for the output for y. So it goes out faster than it goes up, but it does go up. So we thought about the domain for this function. Thought about the domain for it. It would basically be from 0 to positive infinity. And the range of this function, look for all the possible y values, it never exists below this line. So the smallest y value is 0. And it goes up forever. So it also goes to positive infinity. In this case, range and domain are the same thing. But you can clearly see the range and domain in front of the function. We could have found the range by looking at what makes the denominator, the radicand, greater than 0. So one way we could find the domain is take the radicand, set it greater than or equal to 0. And actually that is your domain. So domain is, in this case, when x is greater than or equal to 0. So basically all the positive numbers, including 0. In the next function, what you should have saw was that the range is slightly different. Actually start here at -1 and then went outward. So from -1 to infinity is this domain. So you may have an idea what it's doing. If I added 1 here, you may understand transformation in the graph. If I have +5 there, you might have noticed it went to the left 5. And then it did the exact same thing. So in each one of those, the number here, if it's a plus sign, it ended up being the opposite of it. But the reason why that's true is, if I want to find my domain, which in this case is -5 to infinity, what we can do is, again, set the denominator, set the radicand greater than or equal to 0. Then solve the inequality. You can solve the inequality by subtracting 5. You get x is greater than or equal to -5. So now my domain is this. Domain has to be all numbers greater than or equal to -5. Why? Because if you plug in numbers that's not greater than -5, you get the square root of a negative, which is imaginary, which doesn't exist. So the graph doesn't exist over here. Because plugging any of these numbers to the left of -5, you want to get the square root of negatives, which are not real numbers. The range in each one of these are 0 to positive infinity. Bottoms out at 0, goes up forever. So it's the same thing here. So range of both of those is 0 to positive infinity, and the domain has a shift to it. All right, so give you a couple more of those. Make sure you actually copy all that down, because I'm about to erase the screen now. All right, so instead of using our graphing calculator, let's just use what we understand now about these graphs. So we looked at this graph. I wanted to graph it. What's the domain? Can you tell already? you have to figure out what makes that 0 greater than 0. And what you should get is x has to be greater than or equal to positive 1. So I know my graph starts here and goes outward. And this is at 1. In my next one, where it says track 5, you may already know the domain. Has to be bigger than 5. So I start here at 5. And it goes outward. And in this case, we'll look at the graph of this one. I have the square root of x, but the 3 is not underneath the square root symbol. So it's basically what we had at first, this graph, but the plus 3 makes all the outputs shift up 3. So everything moves up 3 spaces. 3, 3. Even this moves up 3. So let's rewrite that. So in this graph, we start at 3, then it acts just like square root of x. So this would be the graph for it. Our domain hasn't changed. Our domain in this function, it's still from 0 to infinity. Our range has, though. In this case, our range is now, it bottoms out right here on this line. It never go beneath that line. That's the line where y equals to 3. So our range goes from 3 to infinity. And that's a 3. So that's the basic graph of square root functions. Let's talk about cube root functions. So all these are cube root functions. Instead of actually using the graphing calculator, we actually do it by hand. We think about our domain, all the possible numbers for x. I can cube root negative numbers. So that little rule of setting it greater than or equal to 0, you don't have to worry about, because you don't have to worry about having imaginary answers. So basically, domain is all real numbers. There's no number you cannot plug in for x. It's like any real number you can plug in for x will always be okay. So if you think about this, in this graph, I'm going to choose just a few numbers around the origin here. So I'm going to use like x to be -1, 0, and +1. So when I plug in -1 for x, we may just know output is going to be -1. Plug in 0 for x is cube root of 0, which is 0. Plug in 1 for x, you get the cube root of 1, which is 1. So we got outputs. At 0, the output's 0. At -1, my output's -1. At +1, my output's +1. It's +1, this is -1. So basically I have some of the curves. It looks like it's a line right now, right? Well, let's go a little further. Output at 2 is going to be whatever the cube root of 2 is. Cube root of 2. Cube root of 2 is equal to, so about 1.26. So instead of being 1, so at 2, the output's slightly above 1. It's about right here. At 3, output's cube root of 3. That's about 1.44. So at 3, output still not very far from 1. It's like 1.44. So it's creeping up very, very slowly. Figure out cube root of 4. Cube root of 4 is about roughly 1.6. So at 4, cube root there is a little bit more than halfway. Somewhere around there. So the graph is really doing this. They're not really asymptoting because they're going to grow upwards forever, and they're going to go downwards forever. We can go downward and upward very slowly. So in that case, our range, we never stop going upward and we never stop going downward. So our domain is all real numbers, and our range is also all real numbers. Either one of those symbols work. So anyway, that's what the graph looks like. So after a while, you kind of see, well, if it's a traction of 1 that shifts to the left 1, it's going to be the same curve. Oh, you know what? Pause the video. You actually graph the next two from what you understand. See, what you should have recognized is all the points here shift to the left one space. So every point that was there all go to the left one space. So here we have the place across the axis. Here we should have an intersection. And anyway, it should do this. So the same curve shifts to the left one. You should recognize in this graph, you graphed it, should be same curve shifts to the right too. But anyway, that's pretty much how they work. And I can change it. I can add like numbers in front there, like 4 times it. That just changes the output. It stretches the output upwards by 4 or downward by 4 and so forth. I can also change the equation by subtracting the x. Well, you're going to see what happens when I subtract the x. If you don't figure it out, basically when you subtract the x on the square root, it should flip everything. So opposed to x going in this direction, it should wind up going like in that direction. But anyway, you're going to see that as you do some of those. Whenever you're in doubt, you should graph it to kind of figure out the pattern. But they all go by a specific pattern that you can kind of find out after you do enough of those. Anyway, I think you're ready to start. With that being said, good luck on tonight's homework.